name is Jongyu, and the last name is Lee. So just like what I have a problem, you have a problem, pronounce the first name, so you can use my last name to call me. And I'm the associate professor in computer science and engineering department. Is there anyone who are not in computer science, not computer engineering? Anyone from the technical management or electrical engineering? Good. So everybody are in the computer science and engineering, so which is good. So I probably but most of them are new faces, but some of them are old faces I'm familiar with. So I'm teaching the database related course. Actually, this course is was taught by another professor, but I have taught several years ago, but which is not my major area. But this time, since the absence of another faculty, I'm in charge of this course. So since the last semester, I'm teaching operating system class, but mostly I'm teaching the database related course. So if you are taking the database course, probably you will see me another time. Also, I'm teaching the big data related course. So if you are taking the big data or data mining course, probably you will see me again. Okay, but anyway, this is operating system class, more focusing on the graduate student. So this is the CPSC503. But I have, when I checked our class roster, we had several undergraduate students also. So this course is listed with CPEG308, right? So in terms of lecture and the class activity, it's the same as the graduate student. But when I decide the final grade, so will be considered separately, which means, for example, if I need to apply the curve, the graduate student and undergraduate student are different. Okay, so by considering the performance and difficulty of the class activity, but mostly, as I mentioned in the previous class in the database, undergraduate students are better than the graduate students. Really, not kidding. So I have no doubt the undergraduate student can follow the lecture and the class activity throughout the semester. So I hand out the syllabus, but you can also find this syllabus from the class website. So if you go to the bridgeport.edu /JELEE, which is also the UB account. If you want to email me, you can use this JELEE 2 letter from the first name and last name. That is my account, bridgeport.edu. Also, you can use it for my website. Then, if you click the teaching, so you can find the list of course offered in this semester. This is in operating system classes, so you can see this website. So class website is just an overview. I'm not going to update frequently this website. So through this website, you can see the overview of this class, like over the schedule and what's going on throughout the semester. But the detailed announcement and all other class activity, we will use the canvas that I'm going to show later. Okay, so the class hour, class time. So my office hour is not Wednesday, the 2 to 3 o'clock. I'm going to update. This is the old one, so I'm going to update and we'll let you know my office hour. For next class. I have GA, the C. Okay.
Hello everyone, I'm G. My English name is Roger, so if you want to call me Roger, it's okay. And this is a core course, so you should pay a lot of attention to this course and work really hard. So I'm here, so if you have some question, you can ask me. I will try my best to solve your problems. And my office hour is Tuesday and Thursday, 1 p.m. to 2 p.m. Dana Hall 234. So if you have some problem, you can come to my office, so I will solve that. So yeah,
I'm going to update soon. So I received this information, but I didn't update it. I update on the class website. Okay, for the syllabus, it is the office hour and the location. Location is the A9 hall, room 234, second floor. You can find the multimedia information group lab. That is the research lab. So he will stay there to have the study and the homework. So you can combine during his office hour. Okay, and mostly the GA is better than me, better than instructor. So please utilize his knowledge and the power. Okay. Mostly he will grade your homework and project and the other class activity. So you can check. In this class, we are going to use the taxable operating system concept. It's my mistake. I wrote the 8th edition. The current one is the 9th edition. But 8th edition is also fine, but the slightly changes the order of the chapter. But mostly 90% are the identical, but it's your responsibility to check which information are missed in the, if you are using the 8th edition. Okay, you need to check. I don't think I put any corresponding, no. So you need to check if there is any missing part. So you can borrow the book from your friend. So who are using the 9th edition, I strongly suggest to purchase the 9th edition, the textbook. I mistakenly wrote the old one. Okay, but you know that this textbook, have you ever seen? It's known as the dinosaur. It's very popular. Even I used this one when I was a student. So it's the 4th edition at the time. It's a long time ago. The author of this textbook is actually professor in the Yale. So sometimes I try to invite him to the classroom to teach some of the parts of the operating system. But anyway, this is one of the bestseller in computer science textbook. Very well organized, and there's frequently, many of the textbooks, they don't update frequently, but this textbook is the update a lot. Even this one has a very new cutting edge technology in the operating system, including virtual machine and some other techniques. Okay. But every time at the beginning of the semester, I mentioned about the importance of the textbook. Some of the students asked me, is it okay to use the PDF file that I can find on the internet? I cannot answer that, okay? If I say the yes, that will be probably illegal, so violate the copyright. So, but if you are, because all of you guys are in the computer science or computer engineering stuff, it's also a good idea to purchase one of the textbook for operating system. Operating system is one of the major area of the computer science and engineering. Without operating system, we cannot use any computer research. We cannot use even any other the application program, even including the program languages. So from time to time, even now, when I write a technical paper, I refer the even textbook that I used 10 years ago, 15 years ago. Still, it's a valuable. It has, believe me, it has. Yeah, as long as you are in the computer science or computer engineering or the IT, information technology area, definitely this textbook will help a lot. So why don't you think about to purchase at this time? I do not have any relationship with him or whatever, but so this is a book for your future also. Definitely, this is the primary material in this classroom. So many students ask a question. I'd like to use the PPT file that I am going to use throughout the semester for your study or the research, whatever. But it's just a supplementary. That PPT file are used for helping my lecture. Okay? That doesn't mean the PPT5 cover everything in this textbook, no. So this is the primary material when you study and when you prepare the midterm and final exam, even for reference. Okay. And grading policy, pretty much I will follow that the grading policy, but not the same. For example, we do not have the term paper, so it will be changing. But mostly half of them are exam, the other half of them for the other activity, including project and the homework. Also 5% is usually for attendance. So as you realize, we have 20 students to call the each and every student name every time. No, we cannot do that. So from time to time, I'm going to check your attendance. So for example, you attend all the class except the date when I call your name. Okay, so you are unblocked. So please try to do your best. Sit on the chair every time. The attendance will be the 5%. The email is the best way to communicate, especially through the Canvas method. I will show you the Canvas because most of the students are continuing, so you already use the Canvas, right? So you can send a message through the Canvas. That is the best way to communicate with me. If sometimes the student email me through directly email me using the non-UB account. Sometimes it can be classified as the spam mail or sometimes delay to reply. So please use the Canvas message. Okay. And this is the schedule for our students. Pretty much I try to cover the one chapter for each week, mostly, but sometimes, for example, thread, we don't need a lot of time, but chapter 3, process management, definitely we need more than a week. So it can be a little bit change it, but overall, I try to cover one chapter for each week. Then pretty much 13 to 14, one more. If we have a time, I can cover the one more chapter for virtual machine, but which is not stated in the class schedule. Then we have the midterm and final exam. Midterm is during the midterm week, and the final exam is the final exam week. The midterm exam is set up as the October 16th, but the final exam I will let you know. It's assigned by the registrar office. So if you have any conflict schedule with the final exam, that's the problem of another class. The registrar office actually assigned the specific time and this room, which should not be conflict with the other schedule. Okay. Sometimes I know some of the professors they try to have the immediate specific time, and so it cannot be excused. Okay, so all lecture notes you can find from the Canvas that I'm going to show you. We are going to have the 8 times of quiz. The quiz schedules are in the last column. So I'm not going to announce separately in the classroom. It's your responsibility to check, okay, the due date for each quiz. So you can find the quiz from the probably 1 week before due date from the Canvas, okay, which will be available. For example, sometimes I do not cover the topic that is required for the quiz 1, okay, because of the snowy day, something like that. And GA will adjust the time, so don't worry about it. Okay? So you need to check whether the quiz 1 is discussed in the classroom or not. So mostly, I will let you know if I do not cover it. Then you need to submit the quiz to the Canvas. Also, we have the 3. The project, actually project 0 is not the project, it's a kind of a warming up for your programming. One common mistake in this classroom is are you going to teach any program languages skill? Because I do not have any background in the computer science. Sometimes I have a student from the electrical engineering or technical management. This time it's okay, because all of you guys are from either computer science or computer engineering. But I'm not going to teach any programming skill or program language in this classroom. So that is the reason this course requires, it has the prerequisite for at least the 501. In 501, you learn the object-oriented programming, at least the Java programming language. And anyway, if you are in the computer science or computer engineering, you should be able to use at least one program language, right? So you can use any program language. For that, Project Zero. Project Zero is kind of the communication between the multiple processors. At the time, you can use the network protocol like the SOCAMP program or any other IPC, for example. If you are using the Java, it doesn't matter. So as long as you satisfy with the condition requirement in the project description, you can go to the canvas, then find the project description. Then you can understand. It's kind of the CH1 paper, the kind of such a game, simple game. Then project 1 and project 2, you will implement. Project 0, warming up project is individual. So, which means that each student needs to submit the source code and README file. But the project 1 and 2 are the group by 3. It's not individual. That's good, right? So actually, I'd like to have the individual project, but since we have too many students to grade correctly, it's totally impossible. So I cannot manage the 60 students. So we will have the group project. So you can form a team by 3. Okay. So you can form a team by 3. Then when you submit the first project, you need to inform your project member. So each team can submit one copy to the canvas. Then the other members will be graded with the same score. Okay. So project 1, project 2, you will implement the two of the algorithms that we are going to cover in this classroom. So I will explain the detail when we cover that topic, and approaching when the due date is approaching, I will explain about each project details. So for example, project 0 is due on the February 19th. Okay, so you can check the project. You can go to the canvas. And I know this view is different from yours because it's an instructor view, but pretty much you can find. You can see the schedule, the due date of the quiz or the project, right? And if you go to the quiz, you can find the PDF file. Then you can do your homework and submit to the canvas. And also project. So project 0 is a warming up programming. So using any program language, you can use any there is no restriction or the limitation, or so you can use any program language as long as you can you satisfy with the requirement, you will get the full credit. For example, here this is kind of implementation of the simple game CH1 paper. So you have the main process, and you are going to create the two processes. So child 1 and child 2, they need to communicate each other. So you will decide to randomly generate one of these. It can be 0, 1, 2. Then you will decide which is the winner, then notify to other to understand how the process are communicated. Okay? That is the main. Also, another thing is it's kind of warming up for project 1 and 2. So if you realize you do not have enough skill, then you need to study hard for that programming to implement it successfully. The first and the second processor, the project. Any question? So you don't have to inform your team right now. Instead, when you submit your the project 1 at that time, you can inform. So you don't have to submit each member. No, only one submission from each team. But when you submit your source code and the readme file, you need to inform who is the member in your team. So this is the canvas that anyone who never used the canvas, pretty much everybody has the experience. So we are going to use the canvas tool for the class tool, so you can submit anything. Just in case we have the snowy day, so depending on our progress, sometimes if we have extra time, I can cover the missing part in the next class. Otherwise, if we are in a hurry, sometimes I'd like to use this video conferencing tool. Okay, so using video camera, so I'd like to have the online class using this tool. So in case we have the snowy day, I will email it to you. Okay, so at that time you don't have to come to the UV school. So just stay at your home as long as you are connected, so you can actually attend the class. And also the video taping is not for the alternative way of taking the class, it's for future use. Okay. However, I'm going to discuss with the department and also GA, the pressing, so whether we can post to the available website, then those who want to watch once again for your study, then I will talk about that availability later. Okay, any questions? Good. So, this is probably the last handout. I'm not going to provide any printed handout because it's too many students, also the rest of the paper. So you can find all the material from the Canvas, not the class website. Class website is just an overview of the class. It's like a syllabus research. You can find all the material from the Canvas. So if you miss the class, do not ask individually what's going on and what is the homework, so you can go to the Canvas or class the Canvas and check the message, so you can get all the information that are required. Okay. So in this class we are talking about the operating system. To understand the operating system, so we need to first understand what is a computer itself. What is a computer? I asked the same question in another class in the database system. So some of you guys already know the answer. What is a computer? So computer itself, I think it will be better. So computer itself, when we learn the computer is kind of a person who computes. It's not interesting because some of you guys already know the answer. The computer is a person who computes. Okay, actually it's not person, it's a machine, right? So everybody is in a computer science or computer engineering department, which means computer is our major tool that deal with in the classroom and until you graduate. Even after graduate, you will live with such a computer. Okay? So you will get a job around the computer. Then what is a computer, by the way? What's this? Usually I use this rectangle to represent computer. This is our computer. It can be called as a server, computer, it doesn't matter. So what is the main component of a computer? Why don't you remind that you learned in your computer architecture? Operating system? So using operating system, can you build a computer? No. First, you need CPU. It's a central processing unit or microprocessor, something like that. NPU, MPU, CPU, whatever. It's a central processing unit. What is the main role of the CPU? Process the data. Really? What kind of data? Binary data. So if I give the 0 or 1, can the CPU can process it? I don't think so. It can process.
Moving data from one register.
Moving what kind of data? Moving means, so actually the CPU can understand instruction. Okay? So using instruction, we can move the data, as he mentioned. So we will see that part a little bit later. Anyway, it can process something, data, right? It's actually instruction. So it can process instruction. We will see what is the instruction again. So that is the CPU. Another
Process. Registers.
register actually is the storage of the CPU. Right? You can keep such a data or instruction in the register like the AX, DX, CX, DX, what else? DI, CS, SS, DS, EX. Do you know how I can remember that? Because I taught the microprocessor assembly language during the winter break in China. Anyway, so that is the register. Register is the storage. Okay? It's the one of the fastest storage in a computer system. Okay? However, main problem of using register is what? What is the disadvantage of the register?
Power
The
of
size of the net.
Size of the data. For example, if you are using the 16-bit process, AX, you have the AX, EX, CX, DX. How many bit? Only 16 bit for each. Okay? It's a 2 by 2 by 2 by 2 by data. It's word size for each word. Okay? It's too small. Even though you consider DS, CS, this is the actually address of the segment. So to keep the data, so such a at most a 4-word size of data is not enough. So think about your program, application program that you run on your cell phone. Sometimes you need to download 30 megabytes, 100 megabytes size of the program. How can you run such a big size of program using such a small size of storage? How? We need secondary storage. This is a primary storage. Yeah? We need a secondary storage, that is RAM. RAM is one of that example. Memory. So memory is what? It's a secondary storage actually. Okay? Sometimes it's said the primary storage. Because the register itself is not the primary storage, but anyway, it's a backup of the disk the storage. So instead of the using directly AX, BX, or CX register, we can keep such an instruction data into the memory. Then from time to time, whenever they are needed, we can move. Okay, we can call such a data in the memory. Okay, so that is the memory. The RAM is one of the examples. It's a random access memory. Sometimes we have the different types of memory, like the ROM, read-only memory, and but mostly it's a RAM. It's a memory. What else? I/O. We have the many input and output devices. For example, keyboard, mouse, and monitor, printer, and speaker, and bunch of other I/O devices. And also, we have storage. Okay? So the hard disk drive, okay? Storage device. It's called in operating system we call the secondary storage. Okay? So these are the main components. Also, they are connected using what? Bus. So they are actually connected. Using this bus is kind of highway. Each has several lanes. If we are using the 16-bit, it has a 16-bit. Okay? So it actually they have CPU has the several pin. Memory has the pin because each device is actually chip. It's an integrated chip. Okay? So they are connected. So because it can actually send a signal. Signal means 0 or 1 data. Logic 1, logic 0. Logic 1 means you can send the power. If there is a power, it's on. It means 1. It means logic 1. Otherwise, it's nothing. It's a 0. Logic 0. So by combining such a logic 1, logic 0, so using this, it's kind of a wire. Okay? In broad view, it's kind of wire. So using that wire, like this one, we can send the signal, we can send the information, we can send the data. Okay? That is the bus. So bus has sometimes, so it has a data bus, it has address is another important one. Okay? Because its memory is nothing but grid of addresses. Like from 0000 to FFFFF. To find the specific information, you need to know such an address. So for example, such an address, we had, for example, 20 lane. 20 of the address bus, which means we can at the same time send 20 bits of the data. At that time, how many memory address can you represent? 2 to the power of 20. 1 megabyte. Okay? So that was the reason when you learn the computer architecture or CPU. So 8088, 8086 is a 16-bit CPU, or x86, they can use 1 megabyte size of the memory because it has a 20 bus, 2 to the power of 20. Okay? Probably correct. 2 to the power of 20 should be 1 megabyte. Right? So that through and another one is control bus. So using this bus lane, you can send the signal, you can communicate each other. This is the overview of computing architecture. We summarize one computer science subject, computing architecture, in 5 minutes. Okay? So that's one thing you should know before you take the operating system. So if you believe you lack of something computer architecture, why don't you find your old textbook for the computing architecture and read it. It will help a lot. So that is the computer system. Okay. Then How can you? For example, CPU can process a lot of instructions very fast, okay, and the memory provide the additional space, and this one, even provide more space like terabyte, petabyte, and using this device, we can input and output the data, okay? But that is the hardware. Even though you have the Pentium or the iOS, the PowerPC, the chip, very powerful hardware, how can you get the benefit of such a computing power? We need running that system, right? Execute something using what? That is software. Okay? That is actually operating system. So operating system is the program software that can utilize the resource of the computer. So in this semester, we are going to learn this operating system. What is that, and how they are organized. So what kind of program? Pretty much, if you have the idea of the computing architecture, we can pretty much understand what kind of topic we are going to learn this throughout the semester. So to understand that one, let's say, so suppose that we have the operating system, okay? By the way, before that, so there's a power button. So when I turn on this computer, what happened?
The BIOS,
BIOS. What is a BIOS?
basic input output system.
Yeah. For what?
Check all the hardware components.
BIOS is also software, right? This is software. Without software, we cannot get the benefit of the hardware. What kind of software it is? It can check what kind of device are connected to. Actually, these kind of device are on the motherboard. It's fabricated into the motherboard. You can rub it. Okay. So this is the first program. When you turn on your power, this program is located in the ROM. Somebody mentioned about the ROM, read-only memory. Okay. This one is mostly RAM. This one is ROM. ROM is, both of them are memory, they are different. What's the difference?
The power.
ROM, RAM without power is gone. It's a volatile. ROM without power, still there. However, this is a read only. When we make, once you write it, you cannot erase. Some of the ROM you can erase it if you provide a little bit power, electricity, certain level of electricity, like the EPROM, or most popular one is USB, flash drive. Okay, flash drive is also ROM. It's kind of the ROM, but using certain level of power, so you can erase and rewrite. Okay? So this is a ROM, and in the ROM there's a small program. It's called a kind of firmware. Firmware means it's a software reside on the chip. Okay. So even something device like sometimes this kind of device has such a firmware program. Okay. So you probably heard about your firmware should be updated to use, to get, or to connect with the Windows 8 or 9 or something like that. That is a firmware. This firmware mainly automatically started when power is provided, then check what kind of device you have, whether they are connected correctly. And also, the one important thing is, where is boot drive, booting system. So booting system is probably located in the certain hard disk drive because without power you cannot keep the data in the memory. So in certain, that is the reason in the BIOS program you can specify the starting location, like the CD-ROM or the network or C drive or D drive. So that is the main job of BIOS program. Then you can finally locate where is kernel program. What is a kernel program? Kernel program. What is a kernel program? Kernel. So probably you heard about the kernel. So really the kernel or the kernel and here.
Oh yeah. It's the.
What is a kernel program? It's a
It's the core.
core program in your operating system. It's a minimum to run anyway, to utilize, process the hardware. We need to run the program. Okay, that is the operating system. However, operating system itself cover everything. Actually, we will learn what is the definition of the operating system later. But usually every program running on your computer can be considered as operating system. We don't need such an old program right away. First time, we need to minimal program. That is a kernel program, kind of most important part. Small. Also, it is the first process. First process of your system. What is a process? Have you ever heard about a process? No? You need to kill the process, or you need to create the process. You need to understand what is the process to do your warming up project. In the warming up project, you need to create the main process. Then child process, two children processes. So what is a process?
That's a programming execution.
That's kind of the process, but mostly similar as job. Okay. So in terms of such a computing architecture, data structure, what is a process? That's kind of a different definition of a process. Yes, we can say that is a process task. It's kind of a little bit higher level.
Instructions.
Instruction, yes, that's also true. It has what? Bunch of instruction inside. That's also same as program. Okay? So, why don't we discuss about the program first? What is a program? Kernel is also program. Operating system is also program. What is a program? It's a set of instruction. How can you make such a set of instruction? What is the instruction, by the way? So we need to be inside, step by step. We actually inside process, program, and the instruction. What is the instruction? It's the command,
Operations.
operation. More important thing is it's the basic unit of operation in execution, whatever that is. Basic. Basic means it cannot be divided into others. It's atomic. Okay. Once it's started, it's done. Okay. That is the basic unit of processing. Also, it can be processed by the CPU. Okay. That is the instruction. Only computer, your CPU can understand such an instruction. For example, move, add, or the subtract. Such an instruction. Okay? Where can you run such an instruction? Microprocessor class. So you learn the assembly language. So you learn how to code this one. So nowadays, are you using the instruction? Nobody. Nobody uses, nobody code directly such an instruction. How can you make the program? Every day in your programming class, or as long as you are in the computer science, even in the operating system, you need to make the program, right? How can you make such an instruction? Set of instruction, bunch of instruction. How?
Using
IDE,
PC.
PC. IDE can make such an instruction directly. Compile. We are using compiler. Compiler is another program. It's a software. For what? Converting high-level, human-friendly language into machine-level language, which means instruction. Because it's too hard to directly code such an instruction, we need assembly is another high-level language, right? Actually, machine-level language, no, not this one. It's a 0, 1, 1, 0, 0. Probably you have the question in your midterm or final. Convert this one and this one, either way. Nobody knows. Nobody remember after the midterm exam. Even I do not remember. Even this one is hard. However, this one, leave it. We can intuitively understand what's going on. Move the data, add the data. So assembly is a little bit higher level of the language, but still hard. So we are using C or C++. Sometimes even this one is hard. Many of you guys ignore nowadays, but strongly suggest to learn the C language first before you learn the Java. Really. Then nowadays Java or some C#. If you start this language, definitely you cannot understand the low-level language. But this is more important, believe me. And once you understand this part, this is not very difficult to understand what's going on inside. If you do not have such a background, it's kind of, somebody said it's kind of coding machine, which means you will get the less salary. Anyway, so this is a program, high-level language, human-friendly. It's only for human beings because human beings are stupid. They cannot understand this one. No, the machine is stupid. They can understand only this one. Anyway, this is our goal, but it's hard to make this one. So we use assembly. Even this is hard. So C, C++. Nobody uses nowadays C because it's hard to understand. So Java or C# or sometimes component language or whatever because it's very close to the human being. But once it compiles, it creates such a machine code. Then this is the program. Where is it? It's in the hard disk drive. So you can download, you can copy, you can buy the CD-ROM. That is the program. It's in the hard disk drive. It's a storage. Then when you execute this program, run, double click or the touch or the command line, what happened? This one will be. Anyway, CPU need to read the instruction, right? Is there any way to directly read from the hard disk drive? No. Why?
Slow.
Because this is so fast, 2.6 gigahertz. So its clock time is 2.6 gigahertz times, okay? Frequency, which means 2.7 gigahertz CPU. If you have such a CPU, which means the clock speed is 2.6 gigahertz times of the, what is it? This is wave, 2.6 gigahertz times of wave per second. So you need at least 4 clock period to execute one burst cycle. You probably learn your the assembly class underway. If you cannot remember, it's a good idea to just look over your old textbook. And anyway, so that's so fast. What about this one? You know how the hard disk drive is organized? It has a disk, just like the CD-ROM. It's the same thing. Then there is a disk arm, like the moving forward and backward. On tip of the disk arm, there is a head. It can read the data. If it's a hole, there is a hole, it's a 1. Otherwise closed, it's a 0. So you have a bunch of holes on the track cylinder, and it's divided by the track. So you can find the specific data moving forward and backward, and this one is rotated, which means it takes a long time, right? So it doesn't make sense to read directly the instruction from CPU to the hard disk drive. Instead, we are going to use memory cache. That is the von Neumann computing architecture. For Neumann architecture, it has a memory. That's the main part of the von Neumann computer architecture. Okay. Another one is the Harvard architecture.